It starts here, a single cell, invisible to the naked eye. But as we pull back, your entire world, your history, and everyone you've ever loved, shrinks into a pale blue dot. First, we meet the king, Jupiter, a gas giant so massive it could swallow 1,300 Earths without breaking a sweat. Its great red spot is a storm 3 times wider than our entire planet, raging for centuries. It's not just a planet, it's a failed star, a gravitational shield that protects us from the chaos of deep space. But in the grand scheme, Jupiter is just a pebble. Every single day, Jupiter protects Earth from rock, comets, asteroids and more that has a clear path towards our home. But Jupiter's massive gravitational pull is so strong, it sucks everything into its orbit, protecting Earth from getting hit. With a diameter 11 times wider than Earth's, over 1,000 Earths could fit inside Jupiter. It is 318 times more massive than Earth. As a gas giant, it lacks a true solid surface, consisting mostly of hydrogen and helium. Jupiter has the fastest rotation in the solar system, completing a full day in just under 10 hours. The Great Red Spot is an iconic feature centuries-old storm, roughly twice the size of Earth, that rages in Jupiter's southern hemisphere. Jupiter has 95 known moons. The 4 largest, Io, Europa, Ganymede, and Callisto, were discovered by Galileo Galilei in 1610. Jupiter has faint, dark rings made of dust, which were discovered in 1979 by the Voyager 1 mission. Temperatures are extremely cold, averaging around -145 Celsius. Its magnetic field is 54 times more powerful than Earth's. Then, the jewel of the solar system, Saturn, while nearly as large as Jupiter, its density is so low it could float in a giant bathtub. But its beauty hides a violent reality. Those majestic rings are trillions of ice shards and rock, dancing in a gravitational tug-of-war. A masterpiece of physics, yet still, a tiny speck in the void. The iconic rings are composed of billions of pieces of ice, rock, and dust, ranging from tiny grains to house-sized chunks. Saturn is the least dense planet in the solar system, with a density less than water. It has a rocky core surrounded by liquid metallic hydrogen, followed by a gaseous atmosphere. Further out, we hit the windswept world of Neptune, a frozen, blue marble where winds scream at 2,000 kilometers per hour. It is lonely, cold, and dark. Then, Uranus, the tilted giant, an ice world spinning on its side, a reminder that the universe doesn't follow our rules. We are now billions of kilometers from home, but we haven't even reached the terrifying part. Due to a likely ancient collision, Uranus rotates on its side at 98-degree tilt, resulting in extreme, 42-year-long seasons of either constant sunlight or darkness. It is an ice giant with a hot, dense, fluid composition of icy materials like water, ammonia and methane over a small rocky core. Beyond the planets, the rules of physics begin to break. We enter the realm of the black holes. Objects so dense that not even light can escape their grasp. They are the graveyards of stars, warping time and space into a bottomless pit. And then, there is this. Phoenix A, the undisputed titan of the cosmos. At 590 billion kilometers wide, this black hole doesn't just dwarf our planets, it swallows entire solar systems for breakfast. Its mass is 100 billion times that of our Sun. Looking at it, you realize, space isn't just big. It's unthinkable. Estimated at 100 billion solar masses, it is potentially the largest black hole ever detected in the observable universe. Assuming a non-rotating model, its event horizon, Schwarzschild radius, is roughly 295 billion kilometers, which is roughly 50 times the distance from the Sun to Pluto. The black hole is growing at a rapid rate, estimated at 60 solar masses per year. Unlike most black holes that suppress star formation, Phoenix A is in a cluster with rapid, intense cooling of gas, leading to an extremely high rate of star formation with 740 solar masses per year. It was identified by R. Williamson and colleagues in 2010 using data from the South Pole Telescope. The diameter of the black hole's shadow is estimated to be around 590 billion kilometers, which is roughly 100 times the distance from the Sun to Pluto. If placed in the center of our solar system, it would extend well past Pluto, potentially out to the Oort cloud. It would take approximately 71 days and 14 hours for light to travel around its event horizon. It helps astronomers study how massive galaxies and black holes grow, specifically challenging the idea that all large black holes stop star formation in their host galaxies. While 100 billion solar masses is the widely cited figure, some estimates place it within a range of 10⁻100 billion, with some arguments suggesting that its mass is not yet as conclusively measured as others like ton 618. It is 24,100 times heavier than Sagittarius A, which is the black hole at the center of our Milky Way. Its mass is roughly equivalent to 15% of the total mass of the entire Milky Way galaxy and is located roughly 5.8 to 8.6 billion light-years away from Earth. In most clusters, the central black hole emits intense energy that prevents stars from forming. Our Sun, our Earth, our lives, everything we know fits into a microscopic corner of existence. We are a tiny spark in an infinite, dark ocean. But maybe, that's what makes us special. The fact that in a universe this vast, we are the ones looking up, trying to understand it all. Subscribe to our channel if you want to see more videos.